permutations and combinations. As a warm-up, how many different 4-digit numbers can you make using the digits 1, 2, 3 and 4 without repetition? Stop the video and work out all the combinations you can. Here is the list. There are 24 possible 4-digit numbers you can make with the numbers 1, 2, 3 and 4. Now take the letters A, B, C and D. If I wanted to arrange these letters, how many ways could I do it? Stop the video and arrange the letters without repetition. You need to be systematic. So there are 4 choices for the first letter, A, B, C and D. When you choose the third letter, there are now only 3 possible outcomes you can choose for the second letter. That gives us 12 possibilities for the first 2 letters. Then for this last 2 letters, for each of the above, there are 2 possibilities for the final 2 letters. How many is this altogether? Well, it works out to be 4 for the first, times 3 for the second, times 2 for the third, times 1 for the last, which is 24. So there are 24 possible outcomes for arranging 4 different letters. 4 options for the first letter, 3 options for the second letter, 2 options for the third letter, 1 option for the 5th letter. Now take the first 5 letters, A, B, C, D, E. If I wanted to arrange these, how many ways could I do it? Well, the answer is there are 5 possible options for the first letter, times 4 possible options for the second letter, times 3 possible options for the third letter, times 2 possible options for the 4th letter, leaving just 1 option for the 5th. If you multiply 5 times 4 times 3 times 2 times 1, that gives you 120 possible ways of arranging the first 5 letters. Factorial. Another way to say 5 times 4 times 3 times 2 times 1 is 5 factorial, which is written as 5 with an exclamation mark. What is the value of 6 factorial? Stop the video and work it out. Now let's look at arranging 2 A's, B and a C. If I wanted to arrange these letters, how many ways could I do it? We need to think of A, B, C as A1, A2, B, C. Now there are 4 possible choices for the first letter. Again, that leaves us 3 choices for the second. That means there are 12 possibilities for the first 2 letters. Again, leaving another 12 options for the last 2. But If we consider the arrangements of A1, A2, B and C, we may decide there are 24 ways of arranging them. But we must remember, however, that A1 and A2 are the same. If we list the arrangements, we may notice that pairs of the same arrangements are formed, as in the following examples. They are all the same. So although there are 24 arrangements, half of them will be the same. This means that there are actually only 12 arrangements. Mathematically, the number of ways of arranging A1, A2, C, D is 4 factorial. 4 times 3 times 2 times 1. But knowing that A1 and A2 are the same, we need to divide by how many ways there are of arranging A1 and A2. So we divide by 2 factorial. 4 factorial divided by 2 factorial is 12. Now consider 3 A's, B, C and D. To do this, consider how many ways there are to arrange A1, A2, A3, B, C and D. Then consider how many ways there are to arrange A1, A2, A3. You can then work out how many ways there are to arrange 3A's, B, C, D. Write down a rule for the number of arrangements, a set of n objects where R of them are identical. Stop the video and try and work it out. The answer is n factorial divided by R factorial. How many ways there are of arranging n objects divided by how many ways there are of arranging the identical objects. We need to consider a special case. In order for us to be able to use this to expand expressions, we need to consider a special case. We need to consider a set of n objects of which R are of one kind and the rest, which is n minus R, are of another. In other words, we have only 2 different types of objects. For example, 5 A's and 3 B's. Arrangements with objects of only 2 types. So let's go back to 5 A's and 3 B's. If they were all different, there would be 8 factorial ways of arranging them. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. As there are 5 identical A's, we need to divide by 5 factorial. However, there are 3 identical B's, so we need to divide by 3 factorial. So the answer is 8 factorial divided by 5 factorial, 3 factorial, which when simplified and calculated works out to be 56. So there are 56 ways of arranging 5 A's and 3 B's. Now let's consider again the 5 A's and 3 B's and put it into a more algebraic form. The number of ways of arranging n objects, of which R are of one type and n minus R of another, is denoted by the symbol n over r in brackets. We can find this value as n factorial divided by r factorial n minus r factorial. Going back to our previous example of 5 A's and 3 B's, n factorial is 8, r factorial is 5, n minus r, 8 minus 5, is 3 factorial, which gives us 56. Example: 3 A's and 6 B's. How many different ways can we arrange them? Well, n is equal to 9. There are 9 letters altogether. R is equal to 3. There are 3 A's. So n choose R is n factorial over r factorial times n minus r factorial. So 9 choose 3 is equal to 9 factorial divided by 3 factorial, 9 minus 3 factorial, which is 9 factorial divided by 6 factorial times 3 factorial, which when you work it out comes to 84. You can also use a calculator. So going back to the example of 3 A's and 6 B's, n is 9, r is 3. So we want to work out 9 choose 3. To calculate this, type 9 followed by the symbol NCR followed by 3 and press equals. Use your calculator to work out 9 choose 6. Compare your answer to 9 choose 3. Explain your answer. Stop the video and work out. You should notice that 9 choose 3 is the same as 9 choose 6, because it doesn't matter if we choose the 3 A's or the 6 B's. 9 minus 6 and 9 minus 3 will work out to be the same on the bottom. Here are some for you to do. You should be able to complete them in 10 minutes. Stop the video and work them out for yourself.